So I've got a question here for us to take a look at. And this is an example of a type of problem called a mixture problem. And the way I like to think about these is I like to organize the information that we're given into a table, and I'm going to set the table up in such a way that it's really easy to get the equations that we're actually going to solve to get the final answer. Okay, so my table looks like this. Right, I've got 3 rows because I've got 3 things that I'm working with here. I have the 2 solutions that I'm mixing together. I've got the pure alcohol solution. I've got the 50% alcohol solution. And the final solution is the mixture. It's the final mixture that we end up with after we pour all these things together in a jar. Now, the way I've set the columns up, right, there's the total volume, the concentration, and the alcohol volume. And I want you to think about this for a second and really convince yourself that we can multiply across the rows. If I take the total volume of the solution, multiply it by the percentage of the solution that's alcohol, I get the volume that's alcohol. Right? So you kind of think through an example in your head. If I have 100 milliliters of something, and 25% of it is alcohol, say, how much of that 100 units is alcohol? Well, it's 25% of 100, right? So we're going to multiply across the rows here. Okay, so let's just walk through the question one piece at a time, filling in information in the chart. Right, so the question starts off, how much pure alcohol? Okay, great. That's what we're trying to find. Right, so I'm going to put a variable in the pure alcohol volume. That's what we're looking for. And it's pure alcohol, which means the concentration is 100%. Right, so I'm not going to put 100%. Remember, we can't do arithmetic with percentages. I need to convert the percentages to decimals first. So 100% as a decimal is just 1. Right, so that's the value that I'll fill in there. Now, keep reading. Has to be added to a 50% alcohol solution. Okay, so that's 0.5. To get 15 milliliters of a solution that's 75% alcohol. That's the final result that we need. My final mixture needs to have a volume of 15%, and it needs to have a concentration of 75%. All right. So how about these boxes that we haven't filled in just based on what we were told? Right, well, for the 50% alcohol volume, I don't know that. We weren't asked for it, right? So it won't be a part of our final answer. But I still need to put something there, and since I don't know that value, I'm going to put a variable there. I'll put a y. Okay, now I filled in the first 2 columns, which is great because I can get the last column just by multiplying across. Right, so the pure alcohol column, x times 1 is 1x. And the 50% row, 0.5 times y is 0.5y. And the final mixture, 15 times 0.75. Now you get your calculator out. That comes out to 11.25. Okay, great. We filled in the table. Good for us. And now we need some equations. How can we get equations from all of this? Well, look at that total volume column, and forget variables for a minute. If I have, let's say, hypothetically, 10 milliliters of pure alcohol and 30 milliliters of 50% alcohol, and I pour them together into one big beaker, how much do I have? Well, volumes add up. If you take 10 milliliters, add 30 milliliters to it, you get 40 milliliters. Same thing with the alcohol volume values in the last column. Right, so what I'm going to do to get my equations is I'm going to add down the columns. Looking at the total volume column, x plus y has to equal 15. And looking at the alcohol volume column, 1x plus 0.5y has to equal 11.25. And there's my equations. It's a system of equations, but we can solve these. Right, so there's nowhere near enough room here for me to do that. So let me go to a clean page. There's the 2 equations that we left off with. Right. So how are we going to solve this? Well, I'm going to do this, I think, by substitution, because there's a whole bunch of things here that I can solve for one of the variables really easily. So what I'm going to do is I'm going to take that first equation, the x plus y equals 15, and I'm going to solve it for x. And I'll subtract y from both sides, and it turns into x equals 15 minus y. Now I'm going to take that expression for x, that 15 minus y, and I'm going to substitute it into the other equation. Right? So if I replace that x with 15 minus y, the equation becomes this: 15 minus y plus 0.5y equals 11.25. Now we're down to one variable, right? This is something we can solve. So if we combine the two y terms together, it becomes 15 minus 0.5y equals 11 1/4. Subtract 15 from both sides. Negative 0.5y is equal to negative 3.75, and then we divide by negative 0.5, right? And we get the value for y. Y is 7.5. Okay, now we still need x though, right? So now I'm going to substitute again. I'm going to take that value for y, and I'm going to substitute it into the original equation over there, and we get x is equal to 7.5. Excellent. We came up with equations, we solved the equations, but we still need to answer the question. Right, so let me go back to the original here. Right, so you remember what x and y represent. X is the amount of pure alcohol, y is the amount of 50% alcohol. So my final answer is going to be, you would need 7.5 milliliters of the pure alcohol and 7.5 milliliters of the 50% alcohol solution. The question only asked for the pure stuff, so if you only said the first 7.5 on a test or something, yeah, okay, I'd have given you credit for that. That would have been fine. Yeah, we have both numbers, right? So I went ahead and put both of them in here. So there's our solution. If you like this, please don't forget to click on the like button down below. And there's also a subscribe button if you'd like to see more of this kind of thing.